Hey, Mr. Sportel here again, and we are going to go ahead and talk about volume. Now, measurement may be in the past, but volume is going to be what we're going to spend the next couple of weeks on. So I'm just going to talk about the basics right now, and then we can potentially get a video moving into some of the more nuanced things later. So basically, volume is the amount of space inside a 3D figure. And we really care about like rectangles and cubes, right? So you can find the volume of other shapes and things like that, but that's not what they're going to be asked to do this year, so we don't need to concern ourselves with that. Now, there is a formula to find volume, and it is length times width times height, right? There's another formula that I'm not sure if they're going to need, but I'll give it to you anyways. One is base times height, but I'm not going to focus on this any more than just introducing you to this right now, so I'm actually going to just erase it because I'm not sure. I believe it's not any part of our standard that we need to concern ourselves with. So we are going to focus on this one right here. So let's take a look at a couple of examples. And I'm going to just use some textbook pages because we all know that I'm certainly no artist and it would just be a little bit confusing. So if we look at our first example here, we see that we've got a height of 3 inches, a length of 2, and a width of 4. Right, so we're just going to take those numbers and we're just going to plug them in to an equation. Right, so 3 times 2 times 4. Right, so as your students know, it doesn't really matter the order in which we multiply them. So we can just do 3 times 2 is 6, and 6 times 4 would be 24, right? So the volume of our first example here would be 24, right? So pretty simple, as long as our students and your children know their multiplication facts and how to multiply. Make sure that they're double checking those because really when it comes to volume, that's where most people trip up. So the other thing that students need to get familiar with is viewing things like this. And I know it's a little wonky to view, but they have to really be comfortable with hands-on models and things as well. So this here is a shape that would be something that they need to look at. So in this example, they have to pay attention to the height, right? So the height is right here. So there'll be plenty of examples where they give them the length, which is 4 here. Length is 4. The width is 2. And the height is 3. Right? So students really need to understand and be able to grasp that if they see something like this, they need to realize that the rest of these layers are going to be exactly the same as the first one, right? So if we take the height off and we just have a height of 1, right, just one block, the length and the width remain the same. So 4 and 2 is going to be 8, right? So if there's 8 blocks on the first layer, students need to know that when I put these blocks back on, and change the height, there's going to be the same amount of blocks on the other two layers, right? So even if those blocks aren't there, they need to recognize that the second layer, right here, would be 8 blocks, and the third layer would be 8 blocks as well, right? So if you were to add the first layer, the second layer, and the third layer, you would get a total of 24 blocks. And if we use just the regular formula as well, 4 times 2 times 3, 4 times 2 is obviously 8, 8 times 3 is going to get you 24. So doing the formula and adding and counting the number of blocks will get you the same thing. Obviously adding 2 more layers of 8 blocks would be more time consuming, but students need to understand that there are really 2 ways. You can count the total number of cubes, right? So if I were to put my layers back on, I would count and have 24 total cubes. Or I can find the length, 4, width, 2, and height, 3. I don't even need the rest of the blocks on those layers, right? Now, one thing that they might be asked to do is find the volume of a shape that is a composite figure, right? And a composite figure is something that is made up of, and I'll write that down for us, composite. A composite figure is made up of 2 or more 3D figures. And this is really the difficult part for a lot of students with volume, right? And I'll just use this basic shape right here, right? So they see this, and they have a lot of issues. Sorry about that. They have a lot of issues because they say the height is different, right? So the height here is 1 block, but the height here is obviously 2, right? So the way to solve that is you can go about it one of 2 ways. In a couple of scenarios, you may be able to just count the total blocks, right? So for me here, that's not too difficult, right? I just see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So that's not the hardest thing. But more often, they're going to need to know that they have to break apart the figures and then find separate volumes and add together. Right? So what that would look like, number 2, what that would look like for this example right here. I see this and I have 2 figures, right? What I'm going to do is I'm going to break apart the 2 figures, and now I have 2 3D figures, right? So for this figure here, I'm going to find the volume. Well, my length is 4, my height is, or I'm sorry, my width is 2, and my height is obviously only 1 block. So 4 times 2 times 1 is 8, or I could just count the total blocks and get 8, right? So I've taken care of that one. So we'll just call it shape 1, 8, right, for my volume. Now, once they're done with that, they can set this aside and look at their second shape, right? Again, this is a very easy example, but it's more about understanding the thought process. So my length is 1, my width is 2, and my height is obviously only 1 block. Right? So 1 times 2 times 1 is going to get me 2. And then I can just count these blocks here, and we'll say shape 2 equals has a volume, obviously, of 2. Now, I can't just leave this, right, because we need to add them together. And so if 8 plus 2 is going to equal 10, which makes sense, the volume of this shape, if I put it back together, right, is going to be 10. And we can double check that by simply counting the blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So obviously finding composite volume is going to get more complicated and complex than just this, but if they understand the steps to do it, that is more than half of the battle. So I really hope that this helps us understand volume. It's going to be something big moving forward. And as always, if you have any questions, please reach out and I would be happy to help.